Hello, ladies and gentlemen. Welcome back to Physics 20, Vectors, Lesson 1. Sorry. Vectors in 1 and 2 dimensions, Part 2. Now, we just figured out the angle R here is 54 degrees. Now, two ways of noting direction. Rotating direction. So the first one is navigation. Now, this is the common way to do it, and one you have to know. So look at this here, northeast, southwest. If we have an angle of 36 degrees, this is 36 degrees north of east. Now I want to point out with this navigation, it's written backwards, honestly just to confuse you. The first thing you do is you head east. The second thing you do is head north. And the third thing you do is you make an angle of 36 degrees there. Change colors there, I'll make that blue, actually. You stop when you make an angle of 36 degrees. So that is the navigation method. And notice it's written backwards. The last thing you do is the last thing written. You head east, then you swing north to make an angle of 36 degrees. Now why am I pointing this out? Well, there's 54 degrees. 54 and 36 is 90. So there's automatically two ways to write it out. We just found 54 degrees going up like that. And that way you're going north, first thing. Then you're swinging east. And then you stop when you make an angle of 54 degrees. So, here, note that. Two answers are two ways to write out the same answer just to screw with you. And they're both identical. 54 degrees east of north is the same as 36 degrees north of east. And I'll write it N of E. And you have to know that. Okay? Backwards and confusing and two ways to write it. Woohoo! Welcome to physics. Now, so far so good. So this is, back here is 54 degrees. So we go north, then we swing east to make an angle 54 degrees. So it should be semicolon, 54 degrees, east of north. Oh, sorry. Usually people put this in square brackets. Semicolon, square brackets. And then the square brackets emphasize the fact that it is a direction in the vectors. Okay? So this navigation way, north of east, east of north. Wait, it gets worse. Actually, it doesn't get worse. The nicer way is the rectangular coordinate system, or RCS. It's also called the Cartesian method. Those of you in math, remember the Cartesian or coordinate plane? This measures the angle counterclockwise with respect to x-axis. Now remember this because we do a lot of this in Math 30-1. So you're 54 degrees here. We wouldn't look at that. We would look at the 36 degrees relative to the x-axis. So it would just be square bracket, 36 degrees, close bracket. Okay. So there's three ways to write out this answer, and you have to know all three. Yeah, I know. Hurts my brain tube. But fortunately, we're going to do some practice. We're going to add the following vectors. Express the direction of the resultant in using both the navigation system and the RCS system. So, resultant using both the navigation system and the RCS system. RCS. So, 3 meters south and 4 meters east. So you go 3 south and 4 east. There's your resultant. Now, quickly do Pythagorean theorem. I'll prove that's 5 meters. I'm not doing that. 3 squared plus 4 squared. What I want is the angle here. So tan of theta is opposite of adjacent, which is 4 over 3. So angle theta is 10 to the minus 1 of 4/3. Oh, come on, turn yourself on. Inverse tan 4 divided by 3, 53 degrees. So, this is 5 meters, semicolon, 53 degrees. Now, here, first thing we do, wait, brain fire here, my apologies. First thing we do is go south, then we swing east to make an angle of 53 degrees. Sorry, trying not to cough. After COVID and everything, that's kind of scary when I start doing that. Anyway, so 53 degrees east of south. You go south, then you swing east to make an angle of 53 degrees. All right, so far so good? Now, using the rectangular coordinate system, you'd start on the x-axis or east here, and you'd swing around. So what is that? Well, that's 90 plus 90 plus 90 plus 53. It's 270 plus 53 plus 270 is 323. Or we could just say 5 meters, 323. And you notice the rectangular coordinate system is a lot easier, but it's not used as much. Anyway. So far so good-ish. All right. So here's a couple for you guys to try. I'll do the second one with you, then I'm going to pause the recording and we'll try the third one, or compare results for the third one. So for the second one here, you go west 3 and 8. So Pythagorean theorem resultant, a squared plus b squared equals c squared. 8 squared plus 3 squared equals the resultant squared. Resultant squared is 64 plus 9, which is 73. Square root of 73, 8.54. The big question is, what's the angle? Well, try it this way. That's not what I wanted. Sorry, wrong one. Inverse tan divided by 3. 69.4, 69 degrees. We can argue about one significant digit, but whatever. So this is 69 degrees. Let me see. Last thing you do, first thing you do is swing west. What the hell is that? Sorry. And then you go north. So you go west, then you go north, make the angle 69 degrees. Okay. Now, if we're doing the rectangular coordinate system, that's this angle here. So that's 180 minus 69 degrees, which is I can't do that in my head anymore. Minus my answer, 110.55, which rounds off to 111 degrees. All right. So I did that kind of quickly, but as I said, I'm expecting you to be following along, not copying out. If you're copying out, yeah, I'm going this way too fast. So pause and record it. Now, I'm going to pause the recording. We'll both do the third one. We'll come back and compare answers, okay? So pause the recording. Hello, ladies and gentlemen. Now, when I did the math, I went 6 meters right, 1 meter down. I got a result of 6.1 meters, an angle of 9.5 degrees. So that is 9.5 degrees south of east because I went east. Then I went south to make an angle of 9.5. And rectangular coordinate system, that's 350.5 degrees. Or 360 minus 9.5. All right, questions? I hope not. If there are, shoot me an email. Otherwise, good luck. And I'll see you in class and on to the next video.